Our goal today is to simplify complex numbers, simplify powers of I, and then do operations with complex numbers. So in order to deal with complex numbers, we first have to have an understanding of square roots. So looking at 1 through 4, it's just a quick recap of square roots. The square root of 16 is 4 because 4 times 4 is 16. Same thing with 81. If you break it down, the square root of 81 is 9. The square root of 12 is not a nice one. So what we have to do is we have to break it down to its prime factorization, and then we look for pairs. And any pairs we pull out, and anything left behind stays inside the radical. If there's more than one thing coming out or staying inside, we're going to end up multiplying them together. Number 4, the same thing. Square root of 48 is not nice, but what we can do is we can break it down into 16 and 3. 16 is 4 times 4. So we're going to take out a pair of 4s, but there's already a number on the outside, so we're going to end up multiplying those. So on the outside now is going to be a 12, and left behind here is going to be the 3, so it's 12 root 3. So we can simplify square roots. But then all of a sudden, we're going to start solving equations that look like this. I squared equals negative 1. You've been told your whole life that we cannot square root a negative, but we actually can. What's happening here is the square root of a negative is not a real solution. What we're going to do is we're going to call it an imaginary solution. So the imaginary part is going to be called I. So anytime you see an I with math, we should be thinking that I is the square root of negative 1. What that does is it allows us to actually simplify negative square roots. So looking at number 5, we have the square root of negative 25. Normally, prior to now, you would have said, hey, that has no solution. But now that we know we can actually take the square root of a negative number, what we're going to do is we're going to kind of envision this as the square root of negative 1 times the square root of 25. The square root of 25, that part's the part we know. The square root of 25 is 5. The square root of negative 1, we're going to say that as I. So the square root of negative 25 becomes 5I. For the next one, it's going to be similar. The square root of 4 is 2, and the square root of the negative 1 part is going to be I. So the square root of negative 4 becomes 2I. Number 7, the square root of negative 24 is not going to be nice because 24 is not a nice number to square root. So instead what we're going to do is we're going to break it down, and we're going to look for pairs once again. We have a pair of 2's, so the pair of 2's is going to come on out of the square root because they are paired up. Everything else is going to be left behind. So the 2 and the 3 that didn't have pairs, we're going to multiply them, and it's going to be a root 6 left behind. But now we have to deal with this negative part. So the square root of the negative 1 becomes an I. So we're going to write it as 2I root 6 because the I came out of the square root. We don't want it to be after the square root because it's kind of hard to tell if it's in or out then. So the I comes just before the square root and after the number you took out. So number 8 is interesting because we have that 3 on the outside. So this is 3 times the square root of negative 16. So I'm going to actually take the square root of negative 16. That's going to be a 4. And then the square root of the negative part is the I. So the square root of negative 16 becomes 4I. We're going to take and we're going to multiply that with the 3 that was already on the outside. So we're doing 3 times 4I, which becomes 12I. So now these are all complex numbers because they have an imaginary part to them. Anything with the imaginary part is going to be called your complex numbers. Complex numbers and i's have an interesting pattern that is formed when you start raising I to different powers. I to the first power, just like anything else to the first power, is just itself. I squared is a little bit different because I is the square root of -1. If we were to take and square both sides, I squared then becomes -1. So then I to the third power is interesting. I'm going to view this as I squared times I. I squared from the last one, that became -1. I is just I, it's just itself. So what's happening is I to the third power is actually -1 times I. That's going to simplify to -I. And I to the fourth power, what I'm going to do is I'm going to view it as I squared times I squared. I squared was -1. So if I actually take and multiply -1 times -1, I to the fourth power becomes a +1. So what we can do is we can actually remember I to the first power is I squared is -1, I to the third is -I, and I to the fourth is +1. And based off of these four values, we can actually figure out I to any power. So looking at number 9, I to the 7th, what I want to do is I want to break down I to the 7th as I to the 4th, and then however many remaining i's there would be. So 7 is going to be 4 i's and 3 i's put together. So I to the 4th, anytime you have a multiple of 4 for your exponent, that's always going to simplify to just 1. And so whatever then is left over after you do your highest multiple of 4, that's really going to be what tells you what this is going to simplify to. So I to the 7th is going to be the same thing as 1 times I to the 3rd. And from above, I to the 3rd power is -I. So I to the 7th is going to simplify to -I as well. Let's take another example of this. I to the 20th. Well, I to the 20th here, this is a multiple of 4. So every multiple of 4, if it's your exponent, is always going to simplify to 1. So if you have a number like I to the 20th, or I to the 8th, or I to the 64th, any of those, any multiple of 4 is always going to simplify to 1. And then we're looking at afterwards how many extras we have, and that's going to tell us what we simplify to in the future. Now, let's take a look at number 11 to see what I mean with that. So looking at I to the 62, 62 is not a multiple of 4. The highest multiple of 4 closest to that, though, is 2. So I know I to the 60th here is going to end up simplifying to 1 because it's a multiple of 4. So what I have to do is I have to figure out 62 is 60 and then 2 extras. So if I to the 60th simplifies to 1, I squared, we look above and we see I squared is -1. That's going to help us figure out what I to the 62nd power is. We're going to do 1 times -1, in essence, -1. So what's happening is you find your highest multiple of 4, and then you look at how many leftovers you have after that. And it's either going to be 1 leftover, 2 leftover, 3 leftover, or 4 leftover. And based off of the leftovers, whatever that equals is going to be what I to that power is. Complex numbers can be added, subtracted, multiplied, and divided. Looking at this, what we're going to do is we are going to add the real parts and the imaginary parts in order to simplify this. So the real parts are the parts without the i's. So 4 plus 3 is 7. The imaginary parts are the parts with the i's. We combine those together. -I plus 2i is 1i. We always write the real parts and then the imaginary. So this is like a plus bi form. This is for your complex numbers. So you combine the real parts, the imaginary parts, and then you write it in a plus bi form. If you see subtraction, we are going to say, wait a second, I don't want to do the subtraction. I'm going to rewrite this as addition, and I'm going to change my signs. So each sign gets flipped for its positive or negative value. So positive 1 becomes negative 1. Negative 5 becomes a positive 5. And now we can combine the real parts and the imaginary parts. So we end up with 6, and then the imaginary parts cancel out. So we're just left with 6. Multiplying complex numbers. So if you see radicals with negatives, you first have to simplify. So we're going to pull the I out and leave the root 6 alone. We're also going to do the same thing with the next one, so it becomes I root 10. Then we're going to multiply the outside parts, the coefficients. That's going to become I squared. And then we're also going to multiply the 6 and the 10. At this point, the square root of 60, I'm going to take 60 and break it down. And we're looking for pairs now. Take out to further simplify. I'm going to bring a pair of 2's out. I have a 3 and a 5 left behind, so 15 is left on the inside. And the other thing I need to do is simplify I squared. I squared is negative 1. So all in all, the square root of negative 6 times the square root of negative 10 is going to simplify to negative 2 square roots of 15. For multiplying complex numbers that already have the I, it's just like your normal multiplication. So we're going to distribute this. It's going to become a negative 10 plus 5I. For my next one, I see I have to use my distributive property. I have to do 2 times negative 6, which is negative 12. 2 times negative 2I, which is negative 4I. 3I times negative 6 is negative 18I. And 3I times negative 2I is negative 6I squared. I see this I squared part here. I to any power can still be simplified, so I'm going to go ahead and simplify this. We have negative 6 times negative 1. I squared becomes negative 1. So this last term actually becomes a positive 6 when I multiply those together. So after I simplify that, now it's an issue of combining like terms. The negative 12 and the positive 6 become a negative 6. The negative 4I and the negative 18I become negative 22I. And again, we're writing it in A plus BI form when we simplify our answer. Our last example of multiplication here has i's to different powers. So what I'm going to do is I'm going to raise everything in the parentheses to the power. This becomes 4i squared times 5i. And so you have a couple of options. You can multiply first, you can simplify first, whatever you would like to do. I'm going to go ahead and do I squared here is negative 1. So I'm really doing negative 4 times 5i, which is negative 20i. If you have I to any power, you do have to continue to simplify it though, because it can be simplified. The very last thing is dividing complex numbers. So when you divide complex numbers, you cannot have any I in the denominator. So we are going to multiply by the conjugate. For number 18, the conjugate here is going to be just that imaginary part. I'm going to go ahead and multiply everything by I to try and get the imaginary part out of the denominator. The numerator is going to be distributed. It's going to become 5i plus I squared. The denominator here is going to become 2i squared. And I'm going to then simplify my I squared. So my numerator becomes 5i plus negative 1. My denominator becomes 2 times negative 1. So if I were to rewrite this, I would write negative 1 plus 5i divided by negative 2. And I'm going to reduce, or I'm going to rewrite each of these divided by negative 2. This becomes a 1/2 plus, actually that becomes a minus sign. So 1/2 minus 5i over 2.